Okay, here's a video for problems 31 and 35 on our chapter 4 practice test. These two problems right here are examples. When we did them in the notes, I said there's two different ways to do them. You could use the identities, but the way that I said is better to do it because it's more like what we've done in the past is to draw out the triangles based on what they're giving you here, with the sine of 60 being the square root of 3 over 2 and the cosine of 60 being 1 over 2. And so I'm going to use that information to draw out this triangle. And so I'm going this route. You could use identities if you're more comfortable with it, but I think this is, like even when I said in class, the more effective way to go about it. And so I'm drawing in a 60-degree angle triangle here. Because the sine is the square root of 3 over 2. Remember, sine is opposite over hypotenuse. So that means the opposite is the square root of 3, and the hypotenuse is 2. In that same triangle, because it's still 60 degrees, the cosine, remember, is adjacent over hypotenuse, which tells me this is 1, and the hypotenuse is still 2, so this all works out. And now to answer A, B, C, and D, I'm going to use this triangle right here. And so the first one is the sine of 30. And you're like, well, there's no 30 on here, but remember, if this is a 60-degree angle, we know that this is a 90, which means this right here is going to be 30. So we do actually have a 30-degree angle in here, not explicitly said right away, but now we can still use this triangle created to answer A, B, C, and D. So the sine of 30, well, again, sine is opposite over hypotenuse, and now that we're using the 30, opposite is 1, hypotenuse is 2, so that's 1/2. For B, that's the cosine of 30. And using, again, the 30-degree angle, we use adjacent over hypotenuse. That's the square root of 3 over 2, because square root of 3 is adjacent, 2 is hypotenuse. The tangent of 60, so now we're going back to the 60-degree angle, still the same triangle. And we go opposite over adjacent. Well, that's square root of 3 over 1, which you could even just leave as the square root of 3. And then lastly, we have the cotangent of 60, which is using, again, the 60-degree angle, but now that's adjacent over opposite, so that's 1 over the square root of 3, and then when you rationalize the denominator, that becomes the square root of 3 over 3. And so that would be how you would do these problems. You could use identities to do them, but ultimately I think this is the best way to go about those problems, and this is what I said during the notes for this when we did this as well. When we go to 6 here, slide 6, problem 35, we're going to do the same kind of thing. We're going to use that this cotangent of the angle equals 5, and then we're going to create a triangle and try to use that triangle to answer A, B, C, and D here. And so first, trying to do this triangle. We have some angle A that we don't know. Okay, and then cotangent is adjacent over opposite, which means this is 5 over 1. So the adjacent here is 5, the opposite is 1, and I don't have a hypotenuse, and I think I'm going to need one, so I'm going to use Pythagorean theorem because this is a right triangle. And so this is 5 squared plus 1 squared equals c squared. 5 squared is 25, 1 squared is 1, this is c squared. And ultimately here we're going to end up with the square root of 26 being my c value. Okay, and now I'm going to use this triangle to do the rest of this problem. So starting with the tangent of my angle A that I don't know what, doesn't matter. The tangent of A is opposite over adjacent, so that's 1/5, just the flip of cotangent. Cosecant of A, well, cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, so cosecant is going to be hypotenuse over opposite, which is the square root of 26 over 1, or just the square root of 26. Cotangent of 90 minus A, this is a tougher one, but if you go to your notes, I did have one of the identities that the cotangent of 90 minus A, so 90 minus the angle that we don't know, that is actually just the same thing as the tangent of A. And so your answer for C is going to be the same as your answer for A, and that is that the cotangent of 90 minus A is going to be 1 over 5, because it's the same thing as tangent. That's based off of an identity, and something that we would have had in our notes in that lesson where we went over identities. Last one is the cosine of A. And cosine is adjacent over hypotenuse. So that's 5 over the square root of 26. And then when you rationalize the denominator there, that becomes 5 times the square root of 26 all over 26. And then that is how you would do those 4 right there. Again, these are based off identities, but it's better to draw out the triangle and see them as such. One like the cotangent of 90 minus a is not something we generally see on the test, but one that is nice to include because it kind of does involve some of that identity work. More questions I will put in different videos just because I want more time to do them.